welcome to day 29 of our 30-day coding challenge from CS and Math. And we're going to continue with what we did yesterday on simulation and probability. We did yesterday a coin flip and a dice roll, and today we're going to just make that a little bit more open-ended. We're going to show you which one doesn't belong here in a second to get your brain kind of flowing. We'll probably code up what we see in there. And then we're going to try hard to create your own scenario, which we haven't done a lot. I wanted to do something a little more open-ended, and it's a fun project you could do if you have a class where you're teaching probability. So jump on Trinket or whatever you're using to code in Python, and let's get started. Now, WODB, sometimes pronounced WODB, means which one doesn't belong. So you may or may not be able to see these in the video, so what I'll do is I'll blow up the screen just a little bit. It might be a little fuzzy, but we're going to call that okay for today. So I'm going to click that, blow this up. That's a little too big. Let's try this. So this is the top two. Hopefully you can see those now. Look through this code, see if you can decide what does that code do. Look through this one, what does this code do? And then if I scroll down to the bottom two, what does the bottom left do and what does the bottom right do? Okay, and if you were with us, like I said yesterday, we did two of these. We did the one on the top left, essentially. We did a function for it and kind of abstracted it out. But this one is a basic coin flip, heads or tails. Tried to give some things to give it away there. And we did the bottom right. So we did these two. Notice how each of these could have its own reason for not belonging, and that's kind of the idea. And we've also made these fairly generic. Instead of saying like the result was a flip, we just called it outcome generically. So I was going to focus for the starting piece today. Let's say you chose this bottom left one. One reason you might have chose this bottom left one is because the outcomes are with an inequality range. So 43 of the outcomes, because it generates 1 to 100, right? And 43 of those, or I should say 42 of those, come out to be a make, a swish in basketball, right? And then if it's 43 or greater, right, it comes out to be a miss. So this was actually meant to model Steph Curry's three-point percentage one year. I think it was 42%. So what we're going to show here is that you can assign more than one value to an outcome, okay, which we didn't do yesterday. So let me just code this up with you here. This is pictured in Scratch, which we have been doing when we try to transition this Scratch into Python. Okay, so it was called outcome. Remember, outcome was a random number, right? Which we said to get our random numbers, we imported a module called random. So we imported random, and then from random, we used randint, a random integer between 1 and 100. Okay, so now if I did that and I printed outcome, right, if I just generated one, it would print one of the random numbers, whatever it is, every time I ran this, between 1 and 100. Okay, so that is the start. Now, I'm going to flip back and forth between the two so we can make connections. If you've never used Scratch, it's actually a great starter place. This challenge, we've been doing this 30-day challenge, has been based on Python. But we've set outcome to 1 through 100, a random number, right? The same code here is matched in Python. If that outcome is less than 43, so let's go back to our code here. I'm going to delete this out. If outcome is less than 43, then we are going to print swish. And that's just text. So if it's not, we are going to print miss. Let's do it upside down. So now if I do this, notice that that one was a make, swish, 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 miss. Now it's not printing the actual outcome, but we've assigned the outcomes. So obviously if it's less than 43, that's 42, 1 through 42, right? So 42% chance is what we've been modeling here, which is what Steph Curry's free throw percentage was. Now in our particular code here, notice that we wanted to loop that in a repeat loop. So all of this code is repeated 10 times. We've been doing most of our repeats. Let's do this after the import. We've been doing 4 loops. Remember, you could do while loops, and there's some other looping structures. But for item in range 10, we want to do all this stuff. This, remember, generates the random number. I don't actually have to do that, but you're definitely going to have, this is going to generate the shot. This is what the code that actually generates the shot. And so I'm going to go ahead and tab all of that over. And now it's in this loop, so we should get a printing of 10 of these. So of those 10 shots, again, this is meant to model Steph Curry. Maybe I'll do that. I don't remember what year this was, but models Steph Curry's 3-point shot. Okay, so this is where it starts to get interesting. So we've got code here that models his stuff. We could even print the percent. So let's go ahead and do that. Let me give just 2 seconds here to pause. So I did a little searching just to see. I believe this was, we did this the 2017-2018 school year. So that was when his field goal percentage was 42%. So we're trying to model 42 outcomes, 1 through 42, that represent a make, and the rest represent a miss. So, maybe what could be good to do here is talk about where to go with it for students. So here's where we went with it that year. That was really good. We did it in Scratch, but essentially I had a few students go out and actually get their own 3-point percentage. So they shot, I think it was 100 shots one night, and they figured like what their percentage was. So I could just say models my, like I'm the student programming, you could just change this to my 3-point shot. And let's just change this to 100 for now. Let's say we were going to create a game where Steph was going to shoot 100 of these, and you were going to shoot however many. Doesn't matter how many you shoot, but they shot 100. So 1 through 100, and let's say of those 100 you made I don't know, 18, just to let's say you made 17. So this is obviously a less than. So let's say you made 17 of them, and this modeled your 3-point shot. Okay. I'll just cut this code out for now and run this code. So now notice that you could model your shot. And what we would want to do is try to create a game where we think it was like a 50-50 chance that you could win this game or Steph would win the game. So obviously you can't shoot the same amount of shots or have them valued in the same way or whatever. We were doing some stuff with expected value at this time. But just being creative with what that would look like. So I'm going to change a few things, pause, and just put some variables in here. I'm going to put this code back in here as well. And to set it up and let you set it up and think about it is let's create some variables in here. One of them would be let's call it Steph makes, initiated at 0, and we'll say Steph. I was really interested in the makes, so I would say Steph total. And then initiate ones for you down here that say my makes, my total. Okay, so go ahead and get that set up and we'll show where to go from there. Okay, so I decided to actually put in a miss as well. So I moved this Steph makes, Steph miss, Steph total. I moved all that underneath the comment. And the only other thing we changed is instead of a print statement, we're going to increment Steph makes up by 1 in the if part. And otherwise, we're going to do Steph miss plus equals 1. Just didn't feel right to not have that else, so I put that in there as well. Now, see how this is indented in line? That means that no matter if it makes or misses, we're going to increment the total shots up by 1. Okay, now that could also be equal to this range value. We could create a variable and put it there. I just wanted to do this incrementing of all 3. And then if you wanted to do the same thing for your 3-point shot down here. So go ahead and get that set up and I will run it here in a second. Okay, so the probability piece, right, is taking the desired outcome, which in this case was the make, and divided it by the total. And obviously there was nothing that was going to print unless I told it to print out. Remember, this quotations we've talked about in a lot of the lessons will print actual text. And then we need to convert our numbers to a string, which is what the str is for. So the thing you'll notice about this is that the percentage is never going to work out in your favor, right? So this game isn't going to work. This currently has him shooting 100 and you only shooting 10. Maybe you shoot the same number, right? And kids would find out, well, it doesn't matter how many you shoot. We got to change something else. So one thing that's interesting is changing the scoring. So think about, like, his could stay worth 3 or maybe decrease or increase, but think about how you could change the totals to make the game interesting. Okay, so well, you know what I did is I took out the Steph probability. So I had this fraction in the print statement, right? And I took that out. Now, a lot of you are probably like, well, the probability is what you'd get by, or I should say the number of makes is actually times 100. The percent, I should say, times 100 would tell you how many makes. So I changed these both to times 100. And then I was like, what if Steph's going to shoot the full 100 shots? But if I only shoot 10 shots, my likelihood of shooting well randomly in any game that we play could be better. So I'm going to take, Steph's just going to get his 3 points, but I'm going to get 10 points for every one that I make. Right, and that seems extreme, but then let's say we play, and it's like, okay, well, Steph, I didn't make any this time because I'm only shooting 10 shots and I'm only shooting 17%. So Steph scored 3 per each and got 114 there. Steph wins, I win, I win, I win, I win. So it seems maybe this is a little high on my end, right? But they could then actually create a variable for who wins and keep track of it and try to make it 50-50. Maybe they could play around with this. Oops. Make it something like 8. And we had a blast with this, just playing around with probability and devising a game that we thought was fair, and it was interesting. So something to consider. We've covered something a little different, and hopefully it was interesting. You could do it something with not basketball altogether, anything that includes probability, just a little bit more open-ended and fun. Hopefully you found it interesting. Hit that like, hit that subscribe, and we'll see you tomorrow for the last day. Thanks.